Okay, now we talk about section 3.2, chapter 3. And here, one of the term that we use is a function. What is functions? All right. So in order to understand that, let's look at this example first. What I did, I listed 3 equations for you here. The first one is the linear equation, which is a straight line. Remember, because the power of x is 1. If the power of x is 1, when you graph it, you see a straight line. And the second one, the power of x is not 1, it's 2. So this is probably a parabola or is a curve. Okay, so it's like something like this. So as you see, it's not in a straight line. The third one also is not a straight line, you know, it is something like this. It's a curve too. All right. Now, when I have these equations and I want to graph it, I normally come up with some points. I come up with some arbitrary points and find the y value, correct? So let's say x is 2. Substitute that number here. Y is 3. X equal -2. I substitute that, -1. So if you see here, for every x that you assign to this equation, you have the different value of y. For every x, you get a different y. x2, y2, x3. The second one, for 2 different x's, when you substitute 2 different x's, you come up with the same value of y. See? With 2 different x's, you come up with the same value of y. These 2 are both functions. They're just the definitions. The third one is not a function. Why not? Because if for 1x, you come up with 2 different value of y, then this is not a function. Like when I put x equal 3 here, radical 4 is 2, and since there is a plus or minus in front of this radical, you always end up having 2 value for y. So when we say it's not a function, means if you assign 1 value of x, see here, we assign +8, but then we come up with 2 different value of y. So if for 1x, you come up with 2 different y, then it's not a function. So we got to keep that in mind. Another way to tell whether it's a function or not is when you have the graph right here. When I have a straight line, let's say I graph a straight line here. This is in case we give you the graph, like this red line. Now, if you see a graph and we ask you to tell whether it is functions or not, there is a test, they call it vertical line test. And what it does, this test, you bring the straight edge and you move that to the right. If this line intersects the line at only 1 point, then it's a function. See, when you move it from left to the right, it crosses your straight line at 1 point only. So it is a function. Okay? So let's look at another one. So you have a parabola like that. Now, when you take a straight line, where you take a vertical line and you move this from left to the right, that line intersects at only one point. See that? At only one point. So in that case, it's a function. So the vertical line test is, again, you take the lines, vertical line, and you move it from left to the right. If intersect your line or the graph at only one point, then it's okay, it's a function. However, in a case like this, let's say you have this kind of graph. Now, when I want to test a vertical line, when I bring a line from left to the right, that line intersect the graph at 2 points. See, not a functions. When you move that line from left to the right, intersect at 2 points. So it's not a function. So this is how to determine by graphing if you bring the vertical line from left to right. If it hit the graph at 2 points, it's not a function. In the case of a straight line or the parabola, when you move it to the right, if you hit the graph at only 1 point, then it is a function. Okay, this is when you do it graphically, and this is when you try to have it by algebra if you have equations. If you give you an equation and we ask you to tell whether it's a function or not. Okay, so in this example here, you understand all these points are, the first point is x and the second point is y. So if I want to show that here on a table, something like this. So the first one, x is 8, y is -3, 9, 1, -4, -4, 1, 1. Look at the case for these two. When x is 9, or when x is 1, the value of y is same. For two different x's, you come up with the same y value, right? Although in these problems, they're asking, does that give you, is that give you a functions? If you're for two x's, you have the one y? Yes. If two different x's give you one value of y is okay, is a functions. So that's the function. What is domain? Domain is all the x's. And range is all the y. You know, the y is range and x is domain. So when we ask you to find the domain, means just list all the x's here. The first number is always x, remember? The first number is always x and the second number is the y when you see a pair. So which one of these has 8, 9, -4, and 1? This one. What is your range? -3, -3, 1, -4. They're just missing the one here. But anyway, it's this one. They're missing a one. They're not missing, in fact, because one is repeated 2 times. So we don't have to repeat one. So this is the one, right? Because one is repeated 2 times. So we don't have to list it 2 times. All right. What are the domain? Remember the first numbers. So for 2 x's, you have 2 different y. Is that a function or not? When you have 1 x and you come up with 2 different y, I'm sorry, for 1 x, you come up with a bunch of y. X remain the same, but y are different, right? Look at this page here. X's are the same, but y are different, right? So that's is indication of not the functions. See? So no, it's not a functions. And it asks you to use the, what's the range? Range is all these numbers. How about this one? -5, -5, 0, 0, 5, 5. How about this one? X is -5, y is -0, 0. See, they don't have situation that for same x's you got 2 different y, or for the same y that. So this is, it is a functions. And you want to, they ask you to find, what is the range? Range is all these numbers, right? And these are all domain. Remember, X is domain and Y is the range. And it is a functions, because for every X, you get its own Y. See, just show like here, for these 2 planets, Neptune and Venus, for 2, we get 1 value of Y. It's like for x1 and x2, you get 1 value of y. It's okay. It's a functions. But is it the same? Yeah. See, for Mars and Jupiter also, you got the same one. Or 1-on-1 or 2-to-1. So it is a functions, right? What is the domain? These are your domain. And these are your range. So remember, whether you have 2 different x's, you come up with 1 y, or 1 x come with 1 y, is indication of the functions. You don't have a situation that for 1 x you got 2 different y. If that was the case, then it wasn't a functions. See here, for one x, you get one y. Another x, you get that, okay? x1 and x2, you get the same y. Or for x, see Saturn, for 1x, you get 1y. These are all indication of the function. You don't have this case. That for 1x, you get two different y. Not a function, because for 1x, you get several different y's, right? If for 1x, you get a several different y, that means it's not a function. What's the domain? What's the range? That. So what you have on the left is your domain, and what you have on your right is your y is your range and x is your domain, okay? Now, you have the graph. Now we want you to use the vertical line. See, if we give you a graph and we ask you to tell whether it's a function or not, see, use vertical line. So what you do is you take the vertical line and you move it to the right. See, it intersects the graph at 2 points. Remember, if the vertical line hit the graph at 2 points or at more than 1 point, then it's not a function. So that's what vertical test is. Let's look at this example here. How about this one, this graph? Is this a function or not, these red ones? See what the vertical test. Vertical test, it hit it at only 1 point. Yes, it is a function. See, it hit the graph with the vertical line. When you move it to the right, it hit the curve at only 1 point. It's not like that one. So it is a function, yes. How about this one? When you do the test. See, in this one, when you do the vertical test, it hit the graph at 2 points. Let me show you here. See, it hit the graph at 2 points. So it's not a function. Now, what's the, find the domain. Domain is all the x's. See, all the x's start from here and goes all the way to infinity, okay? So it starts from -4 bracket, comma, all the way to positive infinity. You see, domain is, see, x does not go beyond -4. You don't see -4 is here somewhere. My graph on the axis does not go below -4, but it goes all the way to the right. So domain, it's from -4 all the way to positive infinity. Range is the y. See, when you have this graph, I'll put it here. It goes like this. It goes all the way to positive infinity to negative infinity. See, this continue all the way up. So the range is what? The range is negative infinity to positive infinity. And do not use the bracket for infinity because we never, bracket means when you reach that point. When you put a bracket means -4 also is one of the answers. But here, for infinity or negative infinity, never use the bracket because that means it is infinite. We won't get to that, okay? So this is domain, this is range, and is not a functions. Let me show you another example. Let's say you have something like this. Look, x goes from here to 2, 3, 4, 5. See, x goes all the way to positive infinity and negative infinity, right? X is domain. So domain goes from negative infinity to positive infinity. But what about the range on the y-axis? The graph on the y-axis, the graph does not go below 2. See? The graph start from here, goes up. Like if I want to read the coordinates of this point is like, what's the y in this one? Well, let's say y is like 4. Like here, y is 6, y is 8. But y does not go, graph does not go below 2. So for the range, what you do, you just say it's goes from 2, comma, to positive infinity. See? It goes all the way from 2 to infinity. The graph, like if I take a point all the way here, see this point have like x is like I don't know 1,000 and y is like 2,000, right? See, so it goes all the y and x both go to infinity, but here the graph start from 2. The y starts, so y doesn't go below. See, you don't have anything here. That's how you find it. See how the x goes all the way to positive infinity and minus infinity? But you don't have any y here, this area is here. Between these two, there is no y. So how do I write the range? Because domain is what? Domain is going minus infinity to positive infinity. Because it goes all the way here, x, and like that. But there is no y here. So for the y, it comes from here. Y, the graph comes from here. So it comes from minus infinity to -5. This is for the range. Is minus infinity and -5. And then, let's use the bracket. And then here, it's -1 here. This point is -1. You see that? This is -1. So the graph starts from -1 and goes up to minus infinity. And then you always put a symbol of U is the union to connect these two. So between -5 and -1, you don't have any y. That's why we have it like that. How about this line? This is a vertical line. See? Domain, this line goes all the way as far as the x, goes all the way here and there. So domain is -infinity to infinity, right? What about the range? It's just one point. It's just right here. So y is just 3. So range is 3. See, it's just 1 point as a y value. It's not tilted. So what if you have a horizontal line like that? Like this line. I'm sorry, vertical line. This is like what line of x equal -3, for instance. Okay. Look, the x is just one x, right? So domain is just -3. But y goes what? Goes all the way to positive infinity and all the way to -infinity, right? So range is -infinity to positive infinity. See the difference of these two? Vertical line, and this is a horizontal line. Now we look at the equations. Now they give you an equation and say, is this a function? Remember, if it's the first degree linear, x equal 1, all the linears are yes. Because here, any number you put for the x, you always get a different number, like x0, y is -2, x1, y is -1, see? So it is a functions. How about this one? X equal y to power of 6. Okay, so like on this one, look. If y, let's say y is 1 here. You put 1 here. 1 to power of 6. X is 5. Now let's say you put -1 for y. Anytime you want to substitute a negative, you should always come up with parentheses. What is -1 to power of 6? -1 times -1 times -1 is +1. So you still have 5. See, this is a case that for one x, you come with 2 different y's. Remember? For 1, 5, you come up with 2 value of y. Is not a functions. No. You could write it like this. You could just write it as y equal to -5x plus 1. See, it's a linear equations. It is a functions. Same thing. Y equal to -5x minus 5 is a function. Okay? So all the linear equations are the function because for one x, you got one y. You put a different x, you got a different y. And the only one who doesn't is when you have for 2 different y, you get a same different x. You know, here, as a matter of fact, when you want to graph this, you should start with y first, right? You know, if you understand it better. If you put 1, it's 5. If you put -1, you also get 5. So it's not a functions, not a functions. All right. Now we deal with these problems that we give you two different functions, f of x and g of x and h of x, right? Find f of 1. F of 1 means this. Go to f functions. F of 1 means take 1 and substitute for the x. Put 1 and put 4x here and here. So it would be 0. That's what f of 1 means. H of 2 means go and find the h function which is sitting next to it. And you want h of 2, okay, h of 2, put the 2 here. It's 14. You know, when you have f of x equal minus 2x plus 2, instead of f of x in fact is the y value, see? When we say f of 1 means in these functions, when x is 1, what is the value of y? Both means the same thing. So then you say 0, okay? That's what f of something means. So f of x is just a y, and f of 1 means when x is 1, what is the value of y? Like here, what does h of 2 means, or h of x? H of x is y. So the equation is this, y equal 2x2 plus 6, okay? So h of 2 means when x is 2, what's the value of y? Which we calculate is 14. So both means the same thing. Now g of 2, g of x is minus 4x2 minus 2x minus 2. G of 2 means four times 4 is 16. Minus 52. Oh, I'm sorry, minus 22, sorry. I'm glad the answer is right next to it. Okay. Now here, find f of 0, means put 0 here. Half of 0 is what? 0. Put 16 here for x. What is half of 16? See, f of 16 means half of times 16. What is half of 16? 8. Minus 16. What is f of minus 16? Means half of minus 16 is what? Minus 8. Use the graph, if necessary, of the function to the right. What an f of 2 is 17. Write the corresponding order pair. What does that mean, f of 2 is 17? F of 2 is 17 means this. Means when you put 2 for x, you get 17 for the y. That's all it means. Okay? So you could find all of this. Like this one is what? This one, you read the X here and the Y from there, okay? Now this one, they're saying find f of 5. Find f of 5. What does that mean, find f of 5? Means when x is 5, what is the value of y? Okay, so you go and find x equal 5, 1, 2, 3, 4, 5, and then you hit the graph, and that give you -3. Okay? So you have the graph and you find it. Okay? For instance, let's say I have an equation like this, look. And they say, what is f of like 7, for instance, right? F of 7 means on the x-axis, find 7 on the x-axis. Go up and read your y. Let's say you read it is 3. Okay? So you say f of 7 is 3. Or when x is 7, y is 3. That's what it means. Like here, what is f of 0? Here. You go up and you put that point. What is that, 2? Then you say is 2. Okay? So that would be end of section 3.2.